We've been designing high-rise structures for almost 30 years now.
How do you ensure that the reinforcements are being properly placed? Have you ever previously designed a building that has experienced any earthquake of some sort?
Yes. In fact, in 2015, there were two major earthquakes in Nepal, Kathmandu.
स्ट्रक्चरल इंजीनियर राजीव दुआ की डिजाइन की हुई नेपाल की बिल्डिंग देखी। भूकंप के जोरदार झटके के बावजूद इस बिल्डिंग में कोई नुकसान नहीं हुआ।
If we were to say Richter scale 6 and Richter scale 8, Richter scale 8 is going to be 100 times having higher energy than Richter scale 6. There were 3 towers that we designed in Kathmandu. Even after 8.1 earthquake, nothing happened to it.
Developer needs to do some measures or safety checks. So how do you ensure that developer is following your design? Hello everyone, welcome to CIVITECH Podcast, where we dive into the crucial topics surrounding structural safety in high-rise buildings. I'm your host Sarthi Goel from CIVITECH Group, and today we have a very special guest with us, Dr. Rajeev Dua. Thank you so much for joining, Dr. Rajeev Dua.
Thank you for having me.
It is a pleasure. Let me tell you something about Dr. Rajeev Dua. He's a very experienced structural engineer and a very passionate person when it comes to safety and stability of a high-rise structure. He did his bachelor's, master's and doctorate from IIT Delhi, securing the highest CGPA, and was awarded NBCC Prize for Excellence from IIT Delhi. So commendable job on that. And as many of you might know, and some of you might have experienced, the recent earthquake of 4.2 magnitude that we faced in Delhi, it was quite literally the wake-up call. Like, it shook us when we experienced something this frightening, and it was something that clicked in my mind that it was something not to be taken lightly, because it is a natural phenomenon and it can occur anytime they want. So situations like these naturally create some panic, and particularly among those segments who are living in high-rise residential societies. So it is a very kind of uneasy situation for them to face. Like, what can we do? What should we do? Is our building structurally safe or not? So these questions pop in mind of every individual who is currently residing. As we can see the skyline growing up in Delhi NCR, might be Noida and Gurgaon. The high-rise structures are popping up. It is a very big fashion today in living in residential societies, which is growing premium day by day. But the safety also needs to go with premium with that.
Yes.
So today I would like to discuss some safety premiums with you, so that we can enlighten our viewers how the building is structurally safe or not. How can they feel safe during a phenomena like this, and what all steps they need to take just as a normal person to ensure their safety.
Thank you, first of all, for having me here. I've been associated with the CIVITECH Group for quite a few years now, and gives me immense pleasure to be here. We've been designing high-rise structures for almost 30 years now, and across India, of course, and certain projects that we've done abroad as well. Our experience on high-rise structures is that if they are designed properly, there's nothing to be worried about during an earthquake or even after that, or even for a heavy squall or wind. So we'll go further on this. I'll elaborate on what I've been saying. But first of all, it's a pleasure being here.
Thank you so much. Thank you for being here. So without further ado, let us start this podcast. So first of all, Dr. Dua, I would like to discuss what will be the key considerations for making high-rise buildings earthquake resistant.
The foremost aspect of structural design for a high-rise building is that it has to be designed in a ductile fashion. Now, there are certain codes which have been formulated by Indian standards. Now, primarily with respect to ductility in the high-rise structures design. The moment we introduce ductility into the structural design, the safety is taken care of. And that is why we have two different codes now. One is on ductile detailing, which is called IS 13920. And the other one is for the tall structures, IS 16700. It was published in 2023. Now, both these codes put together are leading to almost an ensured safety of structures. And there are different levels of safety also when somebody designs these structures. The foremost level, the highest level of safety is immediate occupancy, wherein even after an earthquake, the residents or occupiers can remain there without even fearing anything.
All right.
And as if nothing had happened. This is
Okay.
called the highest level of safety. Now, the second level of safety is life safety. That's the middle level of safety. And most of the codes are ensuring that. And the third is the collapse prevention of the building. So all structures which are designed as per the Indian codal provisions, they would at least ensure collapse prevention and would aim at life safety level of safety level.
All right. So the
Now-
codes that have been put forward by the government. So the
Yes.
parameters of designing is as per these codes,
Yes.
and then you take it forward like the designing parameters and
Yes.
safety
Yes.
nets that you
Yes.
design.
Yes.
All right.
And as I said, there is the highest level of safety is immediate occupancy level, which is required for hospitals because there the services are pretty crucial. And that design is very elaborate and a detailed one. Requires a lot of effort to do that. So on that basis only, we've been designing most of our structures.
All right. Perfect. So the next would be like, have you ever previously designed a building that has experienced any earthquake of some sort?
Yes. In fact, in 2015, there were two major earthquakes in Nepal, Kathmandu.
Okay.
And Richter scale, it was 8.1 and 7.9 within a span of
8.1.
8.1.
That's a
Yes,
huge.
pretty high, pretty
Yes.
high. And just to add another thing, when we say Richter scale 7 and Richter scale 8, the energy imparted by the earthquake to the buildings or structures is 10 times because it's a log scale. So if we were to say Richter scale 6 and Richter scale 8, Richter scale 8 is going to be 100 times having higher energy than Richter scale 6.
Okay.
So just imagine we've been, recently we had 4.2. Just compare it with something like 8.2. Just imagine it is going to be 10 to the power 4 times energy imparted onto that. So there were 3 towers that we designed in Kathmandu. Even after 8.1 earthquake, nothing happened to it. And this stood like a rock. Why? Because we did the highest level of safety design and also went in for a very elaborate detailing on ductility. So these two aspects led to that absolute safe structure even after 8.1, and the epicenter was pretty close to these 3 towers that we designed.
So
And-
they withstood the earthquake.
Yes,
and
yes.
what about the rest of the buildings in that
The rest of the
vicinity?
buildings in the vicinity collapsed. Most of these collapsed because the ductile detailing was not followed in that.
So that was the one particular reason for that.
Yes, and the other reason was they were highly over-reinforced. Now, any structure...
Isn't over reinforcement a good thing in buildings? Like generally, like people think
Yeah.
if the steel is put
Yes.
like beyond the limit, the steel
Yes.
will help then hold the building
Yes.
intact.
Contrary to the belief that if you put higher reinforcement than what is required, there's an optimum level of reinforcement, or Saria as we call it.
Yes.
If we exceed that limit, there's actually window of ductility. You have to have a certain level of reinforcement. This is the upper limit and the lower limit. Your designs should be within that window. If your design's reinforcement is provided higher than the upper level of that window, it is going to be brittle. And if it is brittle, the safety is not ensured. And that is what happened with the other buildings in Nepal.
Okay.
They were heavily reinforced and they collapsed.
So Dr. Dua, how do these modern skyscrapers that have come up like recently in Noida skyline plus the Gurgaon as well, so how do they withstand such seismic forces?
These seismic forces are, taken care of through the structural design, as we said, discussed. And it has to be elaborately designed for ductility. Just to explain what ductility is, when we talk about construction, at that point in time, there are rings within the column reinforcement and there are stirrups within the beam reinforcement. Now, the most crucial point is, which sometimes is missed out on sites, is that the reinforcement rings of the columns must continue through the beam column junction.
Okay.
If that aspect is taken care of, one is sorted. And that is the most important aspect.
The junction is the most critical
beam
point
column junction
during laying the laying the
concrete
reinforcements.
Yes, and doing the pouring
I remember
of concrete.
you visiting our site once, like when we were building CIVITECH strings in the early days, and you specifically came to site and told my engineers that show me the junction, show me
Yes.
these rings. And I was at that time, because I had not so much experience, I was wondering like why only this point is being focused rather than the whole bars, the
Yes.
sectional area kind of thing.
Yes.
So now I get to know through this podcast as well, that how this junction plays a very crucial role.
Yes.
Because
Yes.
usually people, you can call it laziness or you can call it oversight.
Yeah.
People just ignore that fact.
Yes.
But it's so crucial that everyone, even the engineers who are at site, needs to know this point. So
Yes.
this is a very
Yes.
good point that today we
Yeah.
got from you.
Yeah.
Thank you so much.
Thank you. And the second point is all the rings, whether they are in the beams or in columns, their ends have to be bent at 135 degrees. So that loop should be created like that.
So
that
it
is-
should be in the uniformity should be maintained
yes,
through
yes,
that.
Yes, yes.
Perfect. So another question would be like, generally, if we just think about the earthquake situations, and there are so many misconceptions around it. Like, what should normally are the misconceptions around earthquake, and what should people do? Like, if in high rise they're facing such big earthquakes, like in Bhuj you said, and today as like previous few days as well, we experienced the Delhi earthquake. So what should like people do in situations like these?
Okay, for the safety of people,
Yes.
during an earthquake, if you say high-rise structures, only, let's say, lower floor people can evacuate through these staircases, because it's very dicey. The first failure mostly happens of staircases only.
All right.
Lifts must not be used, and staircases should be avoided for the people staying at the upper floors. And that's pretty important.
But the first thing that comes to your mind is you have to escape through the escape route, which is usually
Yeah.
the staircase. So you're
Yeah.
saying we should not use staircase for upper floors.
Yes, for the higher people staying in the higher floors,
Okay.
they should avoid using the staircase.
Staircase.
They should stay indoors and try and get down below a table if feasible,
Okay.
or some structure which is they can hide themselves in. This is primarily to protect the person during all the debris. God forbid if there is an earthquake and there is a failure of the structure, which should not happen if it is designed properly.
Yes.
But if as an extreme case, if that happens, then the best part is to stay under one furniture, any furniture. It could be dining table, it could be any
Just
other
take
table.
shelter wherever
Yes,
you can.
Yes. And also, wherever you have lintels, that those areas also are
The
pretty
beams
good.
that are flowing
Yes.
throughout the roof.
Just below the door.
Okay.
That is also another safe position. Wherein the wind, as I said, we should always avoid at the upper floors going through and trying to go out of the building. That should be avoided.
Okay. So as we talked about design in quite a lot of depth, so your expertise would be giving the design to the developer.
Yes.
But it is the developer expertise to actually execute that design and take it forward as it is.
Yes.
Because you are saying that you are ensuring all the codes and practices, specifically in high-rise buildings where there is multi-level floors. But the developer needs to do some measures or safety checks. So how do you ensure that developer is following your design and it is not deviating, or it is using the correct steel, correct usage of everything, manpower and everything?
Yes.
So how do you ensure that on site?
Yes, so normally there is a routine of tests that one carries out on site. Concrete tests are carried out. Then reinforcement should be ductile enough. That is why most of the people these days are recommending steel grades with a D. D stands for ductility.
Yes.
So that is one.
Even you have given us 550D.
Yes.
If I'm not wrong.
Yes.
You suggested
Yes.
it. But we
Exactly.
had a lot of problems sourcing that, because usually the vendors don't have D.
Yes.
They say it's the same, just take it. Like if you buy a medicine, they say it's the same salt.
Yes.
If they're saying it's just the same thing, you just take it. But you were very specific on that by 550D. So
Yes.
that's the point whole.
Yes. And that's one. And then as we discussed, the placement of reinforcement, which is the most important thing here. Placement of reinforcement, when you say that bending of hooks at
So how do you
135
ensure that the reinforcement are being properly placed on your site specifically, because
Yeah.
you're designing that, so it is your thing that you have to own,
Yeah,
that
yeah.
I have designed
Yes,
this building,
yes.
and it has to be safe
Yes.
from my end,
Yes.
and plus the execution part of it. So
Yes.
how do you take it further?
At every pour of slab, one of our team members or the design engineer visits the sites and ensures that the reinforcement placement is exactly the way it has been designed. So that's pretty important. Yeah.
Perfect. So there are measures and checklists
Yes.
for you
Yes.
towards the developer that
Yes.
you decide. So generally speaking, so if a person is living in a high-rise building
Yeah.
and he doesn't have the knowledge of the steel reinforcement, because everybody cannot be technical,
Yeah.
but how would he ensure as a layman his safety, that today if an earthquake comes or something, God forbid, if something other than earthquake, a wind pressure comes, so how would the structure behave, and how would he be able to see what kind of structure, what kind of structural design has been
Yeah.
proposed to the developer by the consultant for his safety? So
Yeah.
how would he able to actually check for all these? So how would you guide him?
Okay. See, here, as it is, most of such people, who buy an apartment or an office, should normally make it a routine to visit when the construction is going on. And it's always a good aspect to do it. And somebody who's bought it, once the building is completed, the only checks are, one has to, imagine that the design has been done as per the rules or as per the guidelines of the codes. See, as I said, if the designs are as per the codal provisions, the structural safety is ensured. So one doesn't have to worry about. So only thing is, one has to be pretty sure that the designer is capable of doing all this. He owns that responsibility.
So do he has to put trust in those designers, or he can do some checks as well, just
Yeah.
to be double sure?
Yeah.
This is what I'm asking.
Yeah. See, the other thing is here, like in medicine, God forbid if somebody is having an ailment. Today, most of us are literate enough to kind of go to the same doctor who we require. Like suppose somebody is having some neurological issue. He'll certainly go to a doctor who has a specialization in neurology.
Yes.
He would not visit any other doctor. But what is happening is, for earthquake dynamics or wind dynamics, a lot of developers also are not even considering that they should go to a structural designer who is having his master's or doctorate in that very field. Because I'll tell you, there may be a designer who has done his doctorate or master's in construction management. That gentleman, that person would not be entitled to design a structure unless he has a master's in structural engineering. That, if that is ensured by the developer, the residents should be comfortable.
So it's a developer's responsibility to check the qualifications
Yes.
and the expertise of the designer.
Yeah. And not only is, let's say somebody is a master's or a doctorate, which topic is the doctorate in? What is his specialization? That needs to be pretty carefully seen.
But I think there is also a safety net to that as well, because it is mandatory by the government to have the design audited
by
once the
IITs.
design is
Yes.
final by IITs, if I'm
Yeah,
not wrong.
yeah, yeah.
So I think there is this
That
check
is
as
secondary.
well.
Yes,
This is
yes.
a check as well.
Yes.
So pretty much like the seismic activities won't have much impact on the
Yes,
high rise.
yes, yes.
Is that what we
Yes,
can conclude?
Exactly.
And people needs to, obviously they'll need to take shelter,
Yes.
but they need not to worry much about.
Yes, they don't have to panic. They don't have to panic. Yes.
So it's like generally when the earthquake will come, the building will behave in a certain nature,
Yes.
according to design.
Yes.
But everything, rest assured, the safety is already intact.
Yes, it is.
Already embedded into the structure
Yes.
for these situations to occur.
Yes. And the other thing I'll add here, when we talk about 60, 70 floor buildings, which are pretty high, there the displacement at the very top is pretty large, and that may scare someone. So in our recent designs, what we are doing is, we are introducing some other elements into structural design, which will restrict the displacement at the very top. We are using tuned mass dampers, or we are using viscous dampers to introduce into the building or structure, so that not only it is safe, it is comfortable to live in.
All right.
So that is what we are ensuring
So-
for most of the high rises.
So in today's world, I think structural safety is a basic norm, and now we're trying to certainly add comfort to it,
Yes.
so that it can be more dynamic towards
Yes,
the approach.
yes,
So
yes.
I think the future is bright for
Yes.
structural safety as well, and obviously everyone wants to provide the comfort of a home
Yeah.
given the safety parameters, so that the cost and the hardships that
Yeah.
the site face does not require much effort to it.
Yes.
We can easily, like everyone can easily obtain that resource and actually finalize stuff, so that people can live comfortably at their own ease in their
Yes.
own houses,
Yes.
and just feel safe at all the time. So
Exactly.
this is the goal
Yes, yes.
for every individual who
Yes.
is entitled to this project or any project
Yes.
for any case.
Yes.
So I think that is a very nice discussion with you, Dr. Rajeev, today. And I honestly, I have interacted you previously many times, but today I gained so much insights. Like for me as well, it was an eye opener, because
Thank
that
you.
staircase thing that you told me, that was very nice of you to actually tell something. This is really what we see in in today's picture. The developer just highlights the name of the designer, and nothing much comes
Yeah.
of knowledge to the common people who are actually willing to see how the folds happens
Yes,
on the
yes,
back side of the
yes, yes.
site. So it is a very good insight on that. So thank you so much, Dr. Dua, today for joining us, and it was really nice for having you here, and it was a wonderful time speaking with you. Thank you so much.
Thanks a lot. Thank you.